Welcome to Xnoesis. As we prepare to embark upon this extensive journey into the vast, silent depths of the cosmos and the even vaster, often unsettling landscapes of human thought and scientific inquiry, it is imperative that we establish a foundational understanding, a crucial framework for what is to unfold. What we are about to explore, much like the very fabric of existence itself, is a tapestry intricately woven from the most carefully constructed hypotheses, the most meticulously gathered data, and the most rigorously debated theoretical models our collective intellect has yet to forge. And yet, at its very edges, where understanding frays into the abyss of the unknown, it necessarily delves into the realm of the purely speculative. These are not immutable truths presented as unquestionable dogma, nor are they definitive pronouncements carved in stone. Instead, they represent our current best guesses, our most informed conjectures, derived from observations that push the very boundaries of our instruments, our computational power, and indeed, our wildest imagination. And, as is the intrinsic dynamic nature of all genuine scientific inquiry, these assumptions, no matter how elegant in their formulation, how compelling in their explanatory power, or how deeply satisfying they might initially appear, always carry the inherent possibility of being overturned, profoundly refined, or even entirely reimagined by future discoveries, by novel data, or by revolutionary theoretical breakthroughs. Indeed, this very fluidity, this ceaseless striving for a clearer, albeit perpetually elusive, understanding, forms the bedrock, the very pulse, of all scientific endeavor. It is this spirit of boundless exploration, of embracing the unknown with intellectual courage, that serves as the guiding principle upon which this channel, Xnoesis, was founded, inviting you to join in the quiet pursuit of ultimate knowledge. This profound venture into the intellectual frontier of the unknown began for me with a deep-seated conviction, an almost visceral intuition that there exist certain fundamental questions, certain profound areas of investigation, which, if contemplated with sufficient earnestness, with an unwavering commitment to intellectual honesty, and with true bravery, possess the inherent capacity to profoundly disrupt one's settled sense of reality. They can, quite literally, challenge the very foundations of one's perception and understanding, nudging the mind towards a precipice of conceptual disquietude, even, dare I say, a whisper of potential madness. Perhaps, as you have listened to previous reflections offered here, particularly in the longer-form monologues designed to gently guide the mind towards a state of deep thought and eventual rest, you may have experienced a fleeting echo of this sensation, a subtle tremor in your intellectual comfort zone. This experience is particularly pronounced if your disposition, like my own, is one that readily absorbs, deeply processes, and intimately connects with such grand, overwhelming, and potentially unsettling ideas that pertain to the fundamental nature of existence. Tonight, as the world outside gradually settles into its rhythmic slumber, as the ambient sounds soften and the demands of the day recede, we may find ourselves venturing into this abyss of potential conceptual disorientation, with an intensity that promises to surpass any previous journey we have undertaken together. Prepare your mind, therefore, not for a frantic race through facts, but for a measured, deliberate exploration that will gently stretch its limits, challenging deeply ingrained preconceived notions, and inviting a quiet, yet persistent, sense of wonder tinged with a delicate thread of existential awe. Many of us have absorbed the widely disseminated information, a cornerstone of modern cosmological understanding, that our universe, in its current observable form, boasts an age of approximately 13.8 billion years. We are taught, as part of this grand narrative, that its genesis, its magnificent unveiling, unfolded from a singular cataclysmic event colloquially known as the Big Bang. This narrative, powerful in its simplicity, describes an origin point, a primordial moment, from which everything we know, everything we perceive, everything that constitutes our reality, began its magnificent, intricate unfolding. However, even at this foundational juncture, when confronted with such colossal concepts, profound questions immediately surface, questions that begin to dismantle the apparent simplicity of these widely accepted statements. What, precisely, do we mean, in the most rigorous and absolute sense, when we utter the capacious, all-encompassing word, universe? Are we referring solely to that segment of reality, that finite sphere of existence, which is presently accessible to our most sophisticated instruments and our most advanced theories? Or does the term universe encompass an unimaginably vaster, perhaps even infinitely extensive domain, much of which may forever lie beyond the grasp of our perception? And what, in the truest, most absolute, and most ontologically meaningful sense, does beginning signify in the context of such an incomprehensibly vast, ancient, and potentially boundless entity? These are not trivial semantic quibbles, nor are they mere academic exercises in linguistic precision. They are profound philosophical and scientific inquiries that, by their very nature, redefine the boundaries of our current understanding and challenge our ingrained assumptions about ultimate origins. When the assertion is frequently made that the universe emerged from nothing, it is absolutely crucial to understand that this phrasing, while undeniably evocative and often used for explanatory brevity, is a profound simplification, a linguistic shortcut that almost invariably obscures a far more nuanced, complex, and indeed, deeply mysterious reality. It does not, in the precise and rigorous language of theoretical physics and modern cosmology, imply an actual, literal nothingness, a true void, utterly devoid of all properties, all potential, all underlying substratum, all pre-existent conditions. Rather, in the lexicon of deep cosmological discourse, the word nothing, in this highly specific context, more accurately denotes that which we currently lack: the developed conceptual frameworks, the refined mathematical tools, or the sufficient observational data to adequately describe, to definitively characterize, or even to fully comprehend. It points not to an absolute non-existence, but to a vast, unexplored frontier of our collective scientific ignorance, a pre-existent state or condition that lies just outside the grasp of our current empirical and theoretical capabilities. It is a boundary of our knowledge, not an assertion of an empty void. Consider, for instance, the illuminating insights offered by a distinguished theoretical physicist, whose groundbreaking work frequently delves into the very initial moments of our cosmic story, exploring the parameters and conditions that prevailed at the dawn of existence. In an influential article meticulously exploring the nature of the hot Big Bang, this esteemed scholar carefully elucidates that when we cite the widely accepted age of the universe, that familiar and imposing figure of 13.8 billion years, we are in fact circumscribing a very specific and carefully defined epoch. We are referring solely to the period that commences from the precise instant of the Big Bang's initiation, the moment when the universe transitioned into a state we can describe with our current physics, and extends continuously to the present moment. This temporal delineation is not an arbitrary one. It marks the point at which the universe became hot, incredibly dense, and rapidly expanding in a way that our current physical laws, our observational techniques, and our mathematical models can meaningfully describe, analyze, and predict. Yet, and this is a pivotal and deeply significant distinction, this temporal boundary does not, by any stretch of the imagination, imply an absolute void, a literal nothing, preceding it. It does not mean that, before the Big Bang, there was, in a cosmic sense, truly nothing at all. Such an interpretation would constitute a profound misreading, a fundamental misunderstanding of the scientific consensus. Instead, it strongly suggests, with the weight of modern theory behind it, that whatever conditions or realities existed prior to that discernible moment were simply of a nature entirely different from what we now observe, perhaps governed by physical principles yet unknown to us, or existing in a state so fundamentally alien, so utterly outside our current conceptual framework, that to even speak of time or space in a conventional, relatable sense becomes problematic, perhaps even meaningless. And this profound reevaluation of definitions, this stretching of our conventional understanding, applies not only to the concept of time but, with equal and even more mind-bending force, to the very fabric of space itself. Popular scientific narratives, in their understandable attempt to simplify and render accessible immensely complex ideas, often describe the Big Bang by stating that the entire universe was concentrated into an infinitesimally small point, a singularity, at the moment of its genesis. These narratives might further elaborate by suggesting it possessed a finite size, perhaps even smaller than a single atom, or some other similarly microscopic, almost unimaginable scale. These vivid, yet ultimately limited, analogies are often employed in introductory explanations to make the concept more graspable for a general audience. However, such descriptions, while helpful for initial comprehension, almost invariably refer only to the asterisk observable portion of the universe, that vast, albeit finite, sphere of reality from which light and information have had sufficient time, over 13.8 billion years, to traverse the immense cosmic distances and reach our instruments, our eyes, our consciousness. It is crucial, therefore, to grasp that this limited observational perspective does not, in any way, definitively imply that the entire universe, in its absolute, boundless totality, was finite in its spatial extent at that primordial moment of the Big Bang. Quite the contrary. The overwhelming weight of current cosmological evidence derived from meticulous observations of the cosmic microwave background radiation, the faint afterglow of the Big Bang, and the large-scale structure of the universe, consistently points towards a far more astonishing and unsettling conclusion: that the universe, even at its very inception, was, in all likelihood, already infinite in its spatial extent. Its boundaries, if they exist at all, lie far beyond our current comprehension. This assertion is not merely a theoretical flourish, an elegant but abstract mathematical convenience. It is a profound and deeply counterintuitive implication. If the universe was already infinite at the moment of the Big Bang, then it was not just a tiny, incredibly dense point that expanded into a dawn something. Instead, it was an infinitely vast expanse, but one that was uniformly and unimaginably dense, with every infinitesimal region of that boundless space packed with an astounding, almost inconceivable concentration of energy and matter. The Big Bang, from this perspective, was not an explosion into an existing, larger space, but rather an explosion of space itself, a rapid and dramatic expansion occurring everywhere, simultaneously, within an already boundless pre-existent entity. The density was extreme, the heat beyond measure, the energy staggering, but the scale, paradoxically, remained boundless, stretching forever in all directions. This concept of infinity, both in its temporal dimension, as we will continue to explore, and especially in its spatial dimension, the boundless extent of all that is perhaps one of the most intellectually perilous ideas for the finite human mind to grapple with. It is one of those themes that, when contemplated with genuine depth, when allowed to truly permeate the recesses of one's understanding, can indeed lead to that aforementioned sense of profound disorientation, that subtle yet persistent unease, that quiet, internal tremor. It pushes against the very limits of our intuitive understanding, challenging our ingrained, evolutionarily developed notions of boundaries, limits, and finite scales. It is an idea that perhaps one ought not to dwell upon too intensely for prolonged periods, as its implications are truly staggering, capable of inducing a certain conceptual vertigo. But rest assured, as we proceed through this measured, deliberate exploration, the full, chilling weight of these statements, particularly concerning the infinite, will gradually unfold, becoming, if not entirely comfortable, then at least a little more comprehensible within the broader framework of our grand cosmic narrative. The quiet hum of the cosmos invites us to delve deeper, ever deeper, into its enigmatic, boundless heart. Let us now embark upon a journey into one of the most astonishing and deeply counterintuitive cosmological peculiarities known to modern science. It is a phenomenon that, upon initial encounter, often confounds our everyday experience, challenging our ingrained assumptions about perception, distance, and the very fabric of space-time itself. You are, undoubtedly, intimately familiar with the fundamental, ubiquitous principle that the farther an object is situated from an observer, the smaller it appears to be to our senses. This is a constant, an undeniable aspect of our lived reality, a basic truth that grounds our visual perception of the world around us. For instance, when one gazes down from the dizzying, exhilarating heights of an aerial perspective, perhaps from an aircraft soaring silently through the upper atmosphere, the bustling human activity on the ground below dwindles to an almost imperceptible scale, individuals appearing as mere specks, like diligent, scurrying ants navigating their intricate, purposeful paths. This same principle, scaled up dramatically, holds true for the immediate cosmic neighborhood that surrounds our home planet. Consider the celestial ballet performed by our sun and moon, a spectacle that has captivated humanity for millennia. The sun, a colossal thermonuclear furnace, is approximately 400 times greater in diameter than our moon, a mere rocky companion locked in orbit around Earth. Yet during the breathtaking, almost mystical spectacle of a total solar eclipse, the moon, with uncanny and almost perfect precision, almost perfectly obscures the sun's fiery disk. This astonishing alignment is not a coincidence of physical size alone, but rather a direct and elegant consequence of their relative distances from Earth. The moon happens to be situated roughly 400 times closer to us than the incandescent star it momentarily eclipses. The meticulous interplay of intrinsic size and relative distance creates this spectacular, if illusionary, equivalence, a fleeting cosmic embrace. This consistent, predictable pattern, where an object's apparent visual size diminishes proportionally with its increasing distance from the observer, persists across truly staggering cosmic scales, holding true for billions upon billions of light-years of space. As one might intuitively expect, the farther a galaxy resides from our observational vantage point, the smaller, the fainter, and the more indistinct its luminous presence registers in the sensitive detectors of our most powerful telescopes. This seemingly universal law governs our fundamental perception of the deep cosmos, dictating how we interpret the vast, sprawling, and seemingly endless cosmic tapestry. However, and this is precisely where the conventional understanding abruptly dissolves into something far more perplexing, something that challenges the very foundations of our intuitive grasp of geometry and optics. A startling and utterly counterintuitive reversal of this rule mysteriously manifests itself at a particular, profound cosmic threshold. As we peer out to an approximate distance of about 14 billion light-years from Earth, an entirely opposite and deeply unsettling principle inexplicably begins to assert its dominance. Beyond this critical boundary, instead of diminishing in apparent size as expected, distant objects, paradoxically, begin to appear larger the farther away they are from us. This phenomenon, challenging the very core of our everyday intuition, is a profound riddle, a testament to the strange, non-Euclidean geometry and the dynamic, expanding nature of the universe itself. And yet, for all its profound strangeness, for all its defiance of our common sense, this perplexing cosmological anomaly possesses an explanation that, while deceptively simple in its core mechanism, carries with it an undercurrent of profound cosmic melancholy, a quiet sense of the universe's ultimate aloofness. To truly grasp this, we must first confront an often overlooked aspect of our cosmic interaction, an astonishing reality that underpins our very connection to the distant stellar ballet and the grand galactic dance. It might seem utterly incredible, almost beyond belief, but when you direct your gaze towards any star, any galaxy, any faint glimmer of light that pierces the vast canvas of the night sky, you are, at that very moment, directly experiencing the subtle, pervasive gravitational influence of that distant object. It is a testament to the omnipresent reach of fundamental forces. Even if that celestial body is separated from you by truly unfathomable, mind-bending distances, light years, millions of light years, even billions of light years, if its light has successfully traversed the immense cosmic void to reach your eyes, then its gravitational field has also inexorably extended its subtle, invisible reach to your very location. This is because gravity, like light itself, does not propagate instantaneously across the vast emptiness of space. Instead, it travels at a finite, albeit incredibly swift, velocity, the universal speed of light. The information about a gravitational field, much like a photon of light, takes time to travel. Therefore, when you perceive the sun, for instance, in its brilliant, life-giving glory, you are not experiencing its present-day configuration, its instantaneous position or energy output. Rather, you are observing and interacting with its appearance, its gravitational pull, as it was approximately 8 minutes and 20 seconds ago, this being the precise duration it takes for sunlight and gravitational information to journey from the sun's surface to Earth. And this temporal lag extends beyond mere visual perception to the very mechanics of our solar system. The entirety of our planet, the very mass of Earth, is not gravitationally bound to the sun's current instantaneous position in space. No, it is drawn, with an invisible yet undeniable force, towards the location where the sun was situated precisely those same 8 minutes and 20 seconds in the past. This intricate dance of delayed interaction underscores the profound interconnectedness of the cosmos, where every particle, every star, every galaxy is forever engaged in a complex, time-lagged dialogue with every other, a conversation stretching across eons. The peculiar and often paradoxical characteristic of gravity is that while its strength undoubtedly attenuates, it weakens considerably with increasing distance. It never truly vanishes into absolute zero, no matter how vast the distance separating two masses. It is an omnipresent, albeit often incredibly weak at large scales, fundamental force. While it is true that the gravitational influence of exceptionally distant objects, those residing at the furthest reaches of the observable universe, would be extraordinarily difficult, perhaps even currently impossible, for us to directly detect through conventional means, unless, of course, we are speaking of cataclysmic high-energy events, such as the powerful ripples in space-time, gravitational waves, generated by the merger of two supermassive black holes. This does not negate its fundamental, pervasive existence. Gravity, as a fundamental force, is, paradoxically, remarkably feeble at the macroscopic scale compared to, say, the electromagnetic force that binds atoms together, or the strong nuclear force that holds atomic nuclei stable. Indeed, in a simple demonstration of this comparative weakness, one might, without the aid of any special effects, literally overcome the gravitational pull of our entire planet by simply lifting an object, like a pen, from the ground. A small magnet, for instance, can easily counteract the immense gravitational attraction of an entire world, illustrating gravity's relative weakness. However, do not let this apparent feebleness deceive you into underestimating its long-term power. Believe me, the cumulative, pervasive strength of gravity, operating relentlessly across the immense scales of the universe, is more than sufficient to ensure that, in a static, non-expanding cosmos, all massive objects would, given enough time, inevitably collapse inward upon themselves, succumbing to their mutual, attractive embrace. You would, quite literally, never be able to sufficiently distance yourself from a massive object to entirely escape its gravitational embrace, its subtle yet persistent pull. It is a pervasive, inescapable influence throughout the cosmic tapestry. Yet, despite this omnipresent attractive force, our universe, astonishingly, is not collapsing inward. Quite the contrary. We observe something profoundly counterintuitive, and for a long time, deeply puzzling. The universe is actively and relentlessly expanding. And, adding another layer of cosmic mystery, this expansion is not merely occurring at a steady rate, but it is doing so with an ever-increasing, relentless acceleration. This startling discovery, made in the late 1990s, profoundly shook the foundations of cosmology, revealing a universe far stranger, far more dynamic, and far more enigmatic than previously imagined. It utterly challenged the prevailing models of a decelerating universe. Because the underlying mechanism driving this accelerated expansion remains, to this very day, a colossal enigma, a profound puzzle at the heart of physics, cosmologists, in a moment of elegant intellectual humility and placeholder terminology, collectively refer to any hypothetical phenomenon, any mysterious form of energy, capable of instigating and sustaining this cosmic acceleration as, quote, dark energy. Yes, indeed, I am keenly aware that the term dark energy has perhaps become a somewhat ubiquitous, almost cliched refrain, a familiar whisper from nearly every popular science exposition on the cosmos. It might be tempting to dismiss it as yet another abstract, vaguely understood concept, a mere label for our ignorance. But, my friends, I implore you, do not yield to that initial impulse to roll your eyes or dismiss this concept as merely another piece of cosmic jargon, another fleeting intellectual curiosity. Dark energy is, in all likelihood, one of the most profoundly unsettling, one of the most existentially disquieting and, dare I say, truly horrific phenomena, embedded within the very fabric of existence itself. Its implications, once fully contemplated, once allowed to truly sink into the deepest chambers of one's understanding, are far more disturbing than a mere academic curiosity, far more impactful than a simple scientific puzzle. Therefore, please, resist the urge to disengage. The true terror, the quiet dread inherent in this concept, has yet to be fully articulated, its ultimate meaning yet to be thoroughly grasped. A distinguished professor of physics at a prominent state university, a cosmologist deeply immersed in these profound mysteries and actively engaged in the quest for answers, once wrote with striking candor, offering a glimpse into the hidden motivations of scientific endeavor. If you were to ask my colleagues, they would likely profess a noble desire to comprehend the fundamental nature of dark energy, because, they would argue, it holds the key to unlocking fundamental insights into the bedrock of physics and refining our overarching cosmological model. This is, no doubt, a truthful and noble aspiration, a pursuit of objective knowledge. However, she continued, with an almost conspiratorial tone, a hint of something deeper and more primal, I, for my part, know that what truly propels them, deep down, in the quiet recesses of their scientific minds, is a profound and abiding fear. This fear, let me be clear, is not born of personal peril or imminent danger, but of the unsettling, inexorable implications of dark energy for the ultimate, long-term fate of all that is, for the destiny of consciousness itself. The universe expands, and in its expansion, it harbors secrets that can truly chill the soul, whispering tales of ultimate isolation. Let us delve even deeper into this accelerating expansion of the universe, a phenomenon that holds the key to unlocking some of its most profound secrets and, paradoxically, its most unsettling, desolate futures. To truly appreciate its staggering magnitude and its far-reaching implications, we must mentally rewind the cosmic clock, journeying backward in time approximately 13.8 billion years. This takes us to the very earliest, most primordial moments of the universe's existence, to what we might conventionally, albeit still incredibly enigmatically, refer to as its beginning, a conceptual threshold rather than an absolute start. At this profoundly ancient epoch, at the very cusp of the Big Bang, we encounter a moment of staggering paradox, a period during which, for reasons that remain only partially understood by our current science, the expansion of the universe simply, suddenly, and unbelievably accelerated. This wasn't a gentle, gradual inflation. It was an explosive, almost unfathomable surge, a cosmic growth spurt of truly epic proportions. The region of space that was destined to evolve into what we now perceive as our observable universe, that immense sphere of galaxies, stars, and cosmic structures from which light and information have had sufficient time to reach us since the Big Bang, underwent an astonishing, almost unimaginable growth spurt. It expanded in size by a factor exceeding 100 trillion times. To put that in perspective, that's a 1 followed by 26 zeros, an almost incomprehensible number that defies easy visualization. This occurred with a rapidity that utterly dwarfs the speed of light, an observation that might, at first blush, seem to directly violate one of the most sacrosanct tenets of modern physics: the cosmic speed limit. However, here lies the crucial distinction, the elegant loophole in our understanding. The cosmic speed limit, the speed of light in a vacuum, applies only to objects moving through space. It does not, and never has, imposed any constraint whatsoever on the speed at which space itself can expand. The very fabric of reality, the geometric stage upon which all cosmic events unfold, is not bound by its own internal speed limits when it comes to its own stretching and growing, its own dynamic evolution. I understand, deeply, that the human mind, conditioned by the relatively minuscule scales of everyday experience, struggles profoundly to visualize, let alone truly comprehend, numbers of such astronomical magnitude, such dizzying scales of expansion. Our brains are simply not wired to intuitively grasp such extremes. Our evolutionary history has not prepared us for such cosmic vistas. To offer at least a glimmer of tangible understanding, to provide a relatable anchor in this sea of immense numbers, a renowned theoretical physicist, the same scholar whose insights we alluded to earlier regarding the Big Bang's temporal boundaries, offers a compelling and vivid analogy. He writes, "To illustrate the sheer, mind-boggling frenzy of this early expansion, imagine a minuscule patch of the nascent universe, a region so impossibly tiny that it is no larger than the screen of your personal computer, perhaps even smaller. This incredibly tiny, almost subatomic volume of space expanded to encompass the entire scale of the observable universe, or even far beyond it, in a duration of time shorter than it takes a quark, one of the most fundamental particles we know, a constituent of protons and neutrons, to traverse from one side of a proton to the other. This description, while still conceptually challenging, paints a vivid, albeit humbling, picture of a cosmic event of unimaginable speed, scale, and energetic intensity, a truly primordial explosion of space itself. But then, as abruptly and mysteriously as it began, this monstrous, hyper-accelerated expansion, this initial foundational period of cosmic inflation, slowed down. Again, the precise reasons for this dramatic deceleration, this cosmic breaking, remain subjects of intense research, vigorous debate, and ongoing theoretical development within the scientific community. This entire episode of primordial, explosive growth, and subsequent deceleration is encapsulated by a powerful and widely accepted theoretical framework known as the hypothesis of cosmic inflation. It provides an elegant solution to several long-standing cosmological puzzles. Now, a critical and deeply unsettling question arises from this understanding. Is this initial, incredibly rapid expansion, this ancient cosmic inflation, directly linked to the more recent, accelerating expansion we observe today, driven by the enigmatic force of dark energy? We do not, with absolute certainty, yet possess definitive proof of such a direct causal connection. However, and this is where a subtle, chilling implication emerges, a whisper of potential cosmic terror. We currently have no fundamental physical reasons, no established laws or observations that unequivocally forbid cosmic inflation from occurring again. It is not an impossibility within our current understanding of the laws of physics. Imagine, if you will, the profound, unannounced terror of such an event. What if, at this very instant, as you are calmly listening to these words, as your mind gently processes these complex ideas, the universe were to suddenly, unpredictably, plunge into another phase of cosmic inflation? We would, quite literally, not even have the merest fraction of a second to register its onset, to comprehend what was happening, or to experience any sense of alarm, before its effects utterly overwhelmed us. All forms of life, all intricate structures, all physical relationships, all atomic bonds, all matter itself, would be torn apart at a fundamental subatomic level. It would be an event of catastrophic, absolute finality, a complete obliteration of all that is. Such a sudden, unheralded disappearance of humanity, of all life, indeed of all matter as we know it, would undeniably be a horrific end. But then, a truly unsettling, deeply existential question begins to form in the quiet corners of the mind, a question that pushes beyond mere physical annihilation. What, for humanity, what, for consciousness itself, could possibly be worse than the total, instantaneous demise of all human existence? This is not a rhetorical question designed for easy comfort or superficial dismissal, but a genuine, deeply probing query that leads us down an even darker, more disquieting path towards implications that challenge the very nature of identity and reality. And so, with a steady, measured pace, we continue our deliberate journey into these profound cosmic questions. The universe, having navigated this initial turbulent and incredibly rapid stage of inflation, settled into a more measured, albeit still expanding phase. This initial deceleration persisted for billions of years, allowing the cosmos to cool, for matter to coalesce, and for the first stars and galaxies to form. However, approximately 6 billion years ago, a new, equally mysterious, and profoundly impactful chapter began. The expansion of the universe, which had been gradually slowing due to the gravitational pull of matter, inexplicably began to accelerate once more. This profound shift, this cosmic pedal-to-the-metal moment, was not a theoretical construct plucked from thin air. It was a discovery painstakingly pieced together from the analysis of vast quantities of cosmological data, requiring the most sophisticated modern computational algorithms and observational techniques. These complex programs, capable of sifting through cosmic echoes and the faint light patterns from distant epochs, revealed the unmistakable signature of an accelerating cosmos, pushing the boundaries of our observable reality ever outward at an increasing pace. You are no doubt familiar with the often used analogy that the universe does not expand from a single central point, as if it were an explosion sending fragments outward into a pre-existing void. Such an image is profoundly misleading. Instead, the expansion occurs uniformly and simultaneously at all points within space, much like the surface of an inflating balloon, where every point on the surface moves away from every other point. To visualize this more abstract concept, consider a simple yet effective analogy. Imagine a child's toy, a coiled spring that you are slowly, steadily stretching. As you extend the spring, each individual coil moves away from its immediate neighbor by only a very small, incremental distance, perhaps no more than the width of a finger, or a few millimeters. However, if you were to consider two coils situated at opposite ends of this stretched spring, their separation would be far more substantial, perhaps exceeding a meter, even though the local expansion between any two adjacent coils remains small. Now extend this analogy to an unimaginable scale. Picture that coiled spring as being infinitely long, stretching boundlessly in both directions. This mental exercise captures the essence of how galaxies behave within the expanding universe. Each galaxy recedes from its neighbors, and the farther apart two galaxies are, the more intervening space exists between them, and therefore, the faster their relative separation appears to be. Due to this fundamental mechanism of spatial expansion, distant galaxies can appear to recede from us at speeds equivalent to, or even exceeding, the speed of light. Again, it is crucial to remember that this seemingly superluminal speed does not violate Einstein's theory of relativity. Why? Because it is not the galaxies themselves that are moving through space faster than light. Rather, it is the very fabric of space between us and those galaxies that is expanding, stretching, and carrying them along with it. And, as previously established, there are no known fundamental physical prohibitions or speed limits that apply to the expansion rate of space itself, only to objects moving within it. This incessant stretching of space, this dynamic evolution of the cosmic medium, is, in fact, the very reason behind that perplexing paradox we discussed earlier. Why, at certain immense distances from us, objects begin to appear larger the farther away they are located. This phenomenon occurs for precisely the same reason that we are capable of observing objects that are, in their current cosmic moment, receding from us at superluminal speeds due to the expansion of space. Consider this profound temporal distortion. At the time when these superluminal objects initially emitted the light that we are now only just receiving, they were situated significantly closer to us. At that ancient epoch, billions of years ago, the universe was far more compact, far denser, and consequently these objects occupied a larger angular size in the ancient sky, appearing more prominent against the primordial backdrop. Despite the fact that, in the present cosmic moment, these very same objects are now located at vastly greater distances from us, having been carried along by the expanding universe, the light they sent out so long ago has been faithfully journeying through that expanding, evolving cosmos. Crucially, during a specific, earlier phase of cosmic history, the rate of the universe's expansion, as we observed, experienced a temporary, albeit significant, deceleration. This slowdown allowed that ancient light, that precious snapshot from a bygone era, to finally reach us across the immense cosmic gulf. What we perceive, therefore, is not the galaxy as it is now, in its current, vastly distant configuration, but a haunting, ghostly, time-dilated image of a much closer, much younger, and consequently, much larger appearing object, a relic from a different cosmic age. Thus, a profound truth emerges from this temporal and spatial interplay. The deeper we gaze into the cosmic past, the more compact and dense the universe we observe. This means that a galaxy which, in the present epoch, is situated at a greater distance from us than another galaxy, might, at the precise moment it emitted the light we are now receiving, have actually been closer to us than the seemingly nearer galaxy's past self when it emitted its light. This intricate, mind-bending paradox of perception creates the illusion, the profound cognitive dissonance, where increased distance in the present translates to an appearance of greater size from the ancient past, a trick of cosmic light and time. You have, perhaps, been waiting with quiet anticipation for a concrete example, a tangible anchor to ground this abstract concept in relatable reality. Let us consider one of the most distant galaxies ever observed, a faint, ancient glimmer of light known as GNZ 11. The ethereal snapshot of GNZ 11 that we are now able to perceive, painstakingly gathered by our most advanced telescopes, has traversed the immense cosmic void for approximately 13.4 billion years. What this means is that when we look at GNZ 11, we are not witnessing the universe as it exists today, in its current state of grand accelerating expansion. Instead, we are peering back in time, observing the universe as it was a mere 400 million years after the Big Bang, an incredibly early epoch when the cosmos was significantly more compact, more dense, and far less structured than it is at present. Yet due to the incessant, accelerating expansion of the universe over those 13.4 billion years since its light began its journey, GNZ 11 is, in its current spatial location, estimated to be an astonishing 32 billion light-years distant from us. And because of the perceptual paradox we've just discussed, this incredibly distant galaxy actually appears to us to be roughly twice as large as a galaxy of comparable intrinsic physical size, that is, in its current state, only half as far away. This is the profound, mind-bending reality of cosmic perception, where distance, time, and the relentless expansion of space conspire to create an image that utterly defies our intuitive, earthbound grasp of reality. You are, no doubt, familiar with the fundamental definition of a light year. It is the immense distance that light, traveling at its cosmic speed limit of approximately 300,000 kilometers per second, traverses in one Earth year. Intuitively, then, one might deduce that since the universe has existed for approximately 13.8 billion years since the Big Bang, our maximum observable distance, the farthest we could possibly see, should logically extend no further than 13.8 billion light-years. This seems like a straightforward, arithmetically sound and perfectly logical conclusion based on light's finite speed. However, once again, the universe, in its profound complexity, reveals a deeper, more nuanced, and ultimately more expansive truth. Due to the pervasive influence of dark energy, that enigmatic force relentlessly driving the accelerated expansion of space, we are actually able to perceive objects located at distances far exceeding this seemingly logical limit. For many of you, this fact too may no longer be a surprising revelation, having been discussed in various cosmological contexts. Today, the farthest reaches of our observable universe define a vast, spherical boundary with an approximate radius of 46 billion light-years. This immense cosmic sphere represents the absolute limit of what we can currently detect, the boundary beyond which light from any distant object has not yet had sufficient time, even across billions of years, to reach us. And this observable horizon is not static. It is a dynamic, ever-expanding frontier, a moving boundary in the cosmic sea. As time continues its inexorable, relentless march, this cosmic sphere of visibility will continue to grow, pushed outward by the ongoing, accelerating expansion of space. However, this growth will not continue indefinitely into boundless expansion. Through meticulous cosmological calculations, based on our best current understanding of dark energy and cosmic expansion, scientists have been able to project a future, ultimate limit for our cosmic visibility. This ultimate horizon, this final frontier of perception, is estimated to be approximately 33% larger than our current observable sphere, eventually reaching an astounding radius of roughly 61 billion light-years from Earth. But even as this future boundary expands, even as our theoretical reach extends further into the cosmic expanse, a profound and melancholic cosmic farewell awaits. Gradually, inexorably, the faint, ancient images of galaxies like GNZ11 will begin to dim, to fade, and ultimately to vanish from our cosmic awareness forever. This impending disappearance is not because the galaxy itself has ceased to exist or has somehow been destroyed. Rather, it is because the light that GNZ11 is emitting right now, in its current cosmic moment, will simply never reach us. The accelerating expansion of the intervening space between us and that distant galaxy will stretch the light waves beyond the point of detection, effectively rendering them infinitely redshifted and undetectable. This process will eventually carry the galaxy itself beyond our cosmological event horizon, effectively severing any future communication, any future perception, any future knowledge of its present state. This holds true, of course, unless, by some unforeseen cosmic twist, the expansion of the universe were to dramatically slow down once more, a possibility that, while not entirely ruled out by fundamental theory, is not favored by current observational data. At this very moment, as we contemplate its distant, ancient light, the galaxy GNZ11 is receding from us at an astonishing velocity, approximately 687,000 kilometers per second. This velocity is more than twice the speed of light. And while this fact in itself carries a certain weight of cosmic sadness, the realization that we are irrevocably losing connection with vast, once observable swaths of the universe. The truth is far more pervasive, and, in its ultimate implications, far more somber. The story of GNZ11 is not an isolated incident, a singular cosmic anomaly. It is but a single poignant example of a much grander, more inexorable and deeply saddening cosmic process. Consider this staggering, almost incomprehensible statistic. An overwhelming majority, more than 96.7%, of all the galaxies that we are capable of observing today are, even now, effectively disappearing from our future view, succumbing to this very same principle of accelerating recession. Their present light, their future emissions are already lost to us, traveling away into an ever-expanding void that we will never reach, and that will never reach us. And the situation is even more dire when we consider the totality of our cosmic destiny, the ultimate limits of what we can ever know. More than 98.6% of all galaxies that we will ever be able to observe throughout the entire future lifespan of our expanding cosmic horizon have already disappeared from our potential future reach. Their light is on a journey that will never bring them into our causal sphere. In simpler, starker, and more numerically precise terms, if we were to project the total number of galaxies that humanity, or any future sentient intelligence residing in our local cosmic neighborhood, will ever glimpse across the entire span of its existence, that grand total would be approximately 4.7 trillion galaxies. Out of this incomprehensibly vast number, an astonishing 4.634 trillion of them are already, irrevocably and forever, beyond our reach. Even if we possess the ability to travel at the very speed of light, an ultimate cosmic velocity, we would never be able to bridge the ever-widening gulf that separates us from these now inaccessible islands of stars. They are causally disconnected, their present existence forever veiled. This leaves us with a truly minuscule fraction. Only approximately 66 billion galaxies are still, at this very moment, currently accessible to our observation, their light still capable of reaching us in the cosmic future. And I emphasize currently accessible, for this is not a static situation, a fixed roster of cosmic entities. This is a problem that, with each passing cosmic moment, with each tick of the cosmic clock, will relentlessly worsen, gradually diminishing our cosmic vista, shrinking the sphere of our knowledge. Right now, if we make the reasonable assumption that each of these remaining 66 billion galaxies contains roughly the same number of stars as our own Milky Way galaxy, approximately 400 billion stars, this translates to a staggering, almost unfathomable loss. It means that, on average, approximately 60,000 individual stars are disappearing from our future observational reach with every single passing second. To put that into a more relatable time frame, to allow the magnitude of this loss to resonate more deeply, in the duration that it takes you to simply listen to this segment of our cosmic narrative, roughly 50 million stars will have crossed that invisible, insurmountable boundary, their future light forever barred from our perception. We will, of course, for billions of years to come, continue to receive their Marpre-used-out light, the light they emitted before they crossed that threshold, offering us a haunting, ghostly image of their past selves. But any new light, any new information, any new interaction they initiate from this moment forward will never, ever reach us. Their present is forever lost to our future. This loss of observational access carries with it a profound and deeply isolating implication. From this point onward, we are irrevocably disconnected from these vanishing objects. Regardless of any future technological advancements, any scientific breakthroughs we might achieve, any power we might one day wield, we will simply no longer be able to influence them in any way, nor will they be able to influence us. Any information, any potential understanding we might seek to gain about these distant cosmic realms has now become, in principle, utterly inaccessible to us. We have, in essence, lost a vast, unrecoverable segment of the universe, a silent, cosmic farewell to billions of stellar cities. The chilling truth is stark. More than 98% of all the galaxies we will ever be able to observe throughout the entire lifespan of the universe from our perspective are already irretrievably beyond our causal reach. And what of the fate of those remaining galaxies, those precious few that still constitute our local cosmic neighborhood, those that remain gravitationally bound? If the expansion of space, driven by dark energy, is an unstoppable force that will eventually overcome the gravitational bonds between Dyson galaxies, tearing apart the vast clusters and superclusters, but is not strong enough to tear apart the gravitational forces within individual galaxies or tightly bound galaxy clusters, then a specific, profoundly lonely future awaits. Gradually, relentlessly, each remaining galaxy, or each gravitationally bound local group of galaxies, like our own local group, will find itself increasingly isolated. They will slowly, inexorably, drift further and further apart, from all other cosmic structures, becoming solitary islands of light in an ever-expanding, increasingly empty sea of darkness. The night sky of these isolated galaxies, once ablaze with the shimmering lights of countless other galactic cities, will eventually become a canvas of utter, profound blackness, devoid of any external cosmic illumination. Within these isolated galactic islands, the slow, relentless march of time, dictated by the inexorable increase of entropy, will continue its work. The existing stars, finite in their fuel, will gradually exhaust their nuclear furnaces, cooling and dimming until they are nothing more than cold, dense remnants, white dwarfs, neutron stars, and black holes. The particles that constitute matter, under the ceaseless assault of quantum processes, will eventually decay and disintegrate, transforming into more fundamental, ephemeral components. Even the supermassive black holes, those cosmic leviathans that devour light, are not immune to this entropic march. Over truly unimaginable timescales, periods stretching into durations that dwarf the current age of the universe, they too will slowly evaporate, radiating their mass away through the subtle quantum phenomenon known as Hawking radiation, until they too are gone, leaving only ghostly echoes. And what, then, will remain? The universe, in its ultimate final form, will become an unimaginably vast, almost utterly empty expanse of space. Within this chilling, featureless void, the only dominant force will be dark energy, relentlessly driving an exponential expansion, pushing the boundaries of nothingness further and further apart, throughout an eternal, measureless stretch of future time. This chilling vision, this ultimate cosmic solitude, this final, desolate equilibrium, is known as the heat death of the universe. And in its bleak pronouncements, it promises an end, not with a grand, final bang, but with an endless, silent, ever-widening whimper. A slow, fading into eternal quiescence. Here, at this profound juncture, it is vital to pause and emphasize a crucial, often counterintuitive aspect of dark energy. Unlike gravity, which fundamentally operates as an attractive force, drawing masses together and tending to organize structures, dark energy behaves in precisely the opposite manner. It exerts a repulsive force, actively pushing space apart, separating all things. Moreover, and this is a truly bizarre twist, the strength of dark energy, in terms of its density per unit volume, does not diminish as space expands. In fact, its density per cubic meter remains constant, even as the volume of the universe grows. This is fundamentally different from how matter and radiation behave. As space expands, matter and radiation become more dilute, their density decreasing. But dark energy's density remains the same, meaning its total amount increases as the overall volume of the universe grows, accumulating with expansion. This leads to a chilling feedback loop, a self-reinforcing, runaway process that accelerates towards an ultimate emptiness. As the expansion of the universe accelerates due to the pervasive influence of dark energy, the volume of empty space between structures continuously increases. This increase in empty space, in turn, effectively provides more room for dark energy to manifest, strengthening its overall repulsive effect. A greater presence of dark energy then leads to an even faster acceleration of expansion, which further increases the volume of empty space, and so on, ad infinitum. This creates an inexorable, runaway process that will drive the universe into an exponential expansion that never ceases, never slows, never reverses. In such a universe, eventually, all causal connections will be irrevocably severed. Events occurring in one region of the universe will become utterly incapable of influencing events in any other, even infinitesimally distant, region. The light from a star in one quadrant would never reach another. The gravitational influence of one galaxy would never touch another. No signal, no force, no information could bridge the ever-widening chasm. In the ultimate analysis, the universe will consist solely of an empty, endlessly expanding space, imbued with nothing but the omnipresent dark energy, ensuring its perpetual, exponential growth, a realm of ultimate isolation. This ultimate cosmic state, this desolate, endlessly expanding void, is known to physicists as de Sitter space. And, in a profound and almost poetic parallel, it shares a striking resemblance to the very early cosmos during its inflationary stage. Both periods are characterized by an exponential expansion driven by a dominant, constant energy density. However, there is a crucial, fundamental difference that alters its ultimate meaning. Unlike the transient, self-limiting nature of cosmic inflation, which eventually ceased, the expansion of de Sitter space, fueled by dark energy, is predicted to endure forever. It is an eternal expansion, a cosmic trajectory with no discernible endpoint, a truly endless frontier of nothingness. This raises a profoundly philosophical and existential question, one that echoes in the quiet chambers of the mind. Can such an eternal, ever-accelerating expansion, leading to ultimate emptiness and isolation, truly be considered the end of the universe? Or is it merely a transformation into a state so utterly alien, so fundamentally different from our current reality, that our very definitions of universe and end cease to hold their conventional anthropocentric meaning? The very concepts of beginning and end, of being and non-being, become fluid, ambiguous, and deeply challenging to our human-centric understanding. This compels us to reconsider our most fundamental assumptions about existence, purpose, and the grand narrative of the cosmos, forcing a humility of thought. Indeed, the question of what constitutes the end of the universe, or even its beginning, inexorably forces us to confront an even more fundamental, equally perplexing, and deeply unresolved enigma: the very nature of time itself. You see, when we delve into the concept of time within the rigorous framework of theoretical physics, we swiftly discover that it remains one of the most stubborn, one of the most deeply unresolved, and one of the most intellectually humbling mysteries. Despite centuries of profound philosophical thought, groundbreaking scientific discoveries, and the development of incredibly sophisticated theories, no one, not even the most brilliant minds, truly comprehends why time relentlessly marches forward in a single, unwavering direction. It is a pervasive, almost undeniable experience for us, a fundamental pillar of our perception, yet its underlying physical mechanism, its ultimate cause, remains elusive. Consider, for a moment, a simple yet powerful thought experiment. Imagine a microscopic animation depicting a collection of particles, perhaps molecules in a gas, darting, colliding, and interacting within a confined space. As you observe these tiny invisible entities, constantly in motion, ask yourself with quiet deliberation, are these particles moving towards the future, or are they retracing their steps backward into the past? The stark, honest, and profoundly revealing answer is that you cannot definitively know. This is because, irrespective of whether I were to play that animation forward or backward, reversing the chronological sequence of events, the fundamental laws of physics governing the motion of those particles, the underlying equations that describe their interactions, would remain precisely the same. They would appear equally valid, equally plausible, equally consistent with the known physical universe, in either temporal direction. This illustrates a profound principle known as time reversal symmetry. At the microscopic, fundamental level, the physical processes that govern the universe are believed to be either entirely, or at least predominantly, symmetrical in time. This means that if you were to invert the direction of time in the mathematical equations that describe these micro-events, the theoretical assertions that underpin them would remain perfectly valid. The equations would still hold true, and the predicted outcomes, when viewed in reverse, would still align with the fundamental laws of physics. You have, in essence, just observed this remarkable temporal symmetry in action, even if the scale is too small for our everyday perception to register. Now, let us shift our focus to a slightly different, yet equally illustrative, observation, one that resonates more with our macroscopic experience. Imagine a single drop of vibrant, deeply colored ink, carefully introduced into a clear glass of still water. As the ink disperses, gradually, inexorably, it spreads throughout the water, its vivid color swirling and mingling until it achieves a state of uniform diffusion, a homogeneous mixture. Ask yourself with quiet certainty, is this ink separating from the water, or is it irrevocably mixing with it? Here, your answer is immediate, unequivocal, and deeply intuitive. You know with absolute certainty which direction represents the past, the pristine drop of ink, and which represents the future, the uniformly colored water. The ink will always mix and diffuse. It will never spontaneously separate and coalesce back into a single pristine drop. This intuitive certainty about the direction of events is called the arrow of time. This striking difference highlights a crucial point. At the macroscopic level, the level of our everyday experience, an unmistakable and pervasive arrow of time very clearly exists. The world we inhabit is not temporally symmetrical in any practical sense. Teacups shatter into countless fragments but do not spontaneously reassemble themselves into perfect ceramic forms. Stars burn out their nuclear fuel but do not spontaneously ignite from cold, inert ash. Memories accumulate and evolve but do not spontaneously erase themselves in reverse chronological order. Thus, it appears that the sole domain within physics that truly concerns itself with, and indeed largely defines, the direction of time, is the profound concept of entropy. Why is it that, despite your most diligent, painstaking efforts to tidy and organize your closet, with every garment perfectly folded and every item precisely in its designated place, chaos inevitably reasserts its dominion after a relatively short period? Why do your clothes, once neatly arranged, gradually, almost maliciously, devolve into a state of disarray, a tangled mess? To understand this, let us engage in another thought experiment. Envision your closet in a highly ordered state, meticulously organized, with every garment perfectly folded and every item precisely in its designated place. This represents a highly ordered, low-entropy state. Now, simultaneously, attempt to conceive of all the myriad, countless ways your clothes could be arranged, imperfectly, haphazardly, in a state of utter disorganization. Think of them piled, scattered, twisted, a riot of fabric. And the profound truth is this: the number of disordered, chaotic arrangements for your clothes is astronomically, unimaginably greater than the number of perfectly ordered, aesthetically pleasing configurations. There are simply countless more ways for things to be messy than to be neat. Because there are vastly, vastly more ways for a system to be disordered than ordered, the statistical probability dictates that any system, left to its own devices, will naturally and inevitably trend towards a state of increasing disorder. This is the inescapable dictate of the second law of thermodynamics, a cornerstone of physical reality. This law unequivocally states that within an isolated system, the total entropy, a measure of disorder, randomness, or the number of ways a system can be arranged, can only ever increase, or, at best, remain constant. It can never spontaneously decrease. Thus, in your closet, left unattended, a state of disarray will, sooner or later, inevitably prevail. It is a cosmic certainty. You might, at this juncture, raise a valid and intuitive objection. But I can tidy my closet. I fold my clothes and arrange them, thereby reducing the entropy within the closet. Am I then defying the fundamental laws of physics? Not at all. The crucial qualification in the second law is within an isolated system. Your closet, despite its apparent containment, is not, in fact, an isolated system. And you, the diligent organizer, are certainly not isolated from the wider universe. When you expend energy to fold your clothes and restore order, you are actively performing work. You are consuming sustenance, metabolizing food, and expelling carbon dioxide into the surrounding air. Your body generates heat through convection and perspiration, warming the ambient environment. The act of bringing order to your closet necessarily involves the expenditure of energy, and in this process, you are, in fact, increasing the total entropy of the asterisk larger encompassing system, that is, yourself, your body, and your immediate environment, to a far greater extent than the local reduction of entropy within your closet. The net result is always an increase in the universe's overall disorder. This principle has fascinating counterintuitive implications for our everyday lives, illustrating the pervasive nature of entropy. It is precisely why, for instance, if you were to attempt to cool a room by simply leaving the door of your refrigerator open, the room would not, in fact, cool down. Quite the opposite. It would, over time, actually become warmer. The refrigerator, while creating a local area of decreased temperature, lower entropy, within its insulated confines, does so by expending electrical energy to pump heat out of its interior. This energy is then dissipated as heat into the room, increasing the overall disorder of the room plus refrigerator system. Every single one of our attempts to impose order upon one specific part of the world invariably generates an even greater degree of disorder, typically in the form of dissipated heat, in another, often less obvious part of the world. It is the inescapable tax of organization. And it is here, in this ubiquitous, relentless march towards disorder, that we uncover a profound, albeit still hypothetical, connection to the very experience of time itself. We do not yet possess definitive proof, but it is entirely plausible and indeed a leading scientific hypothesis that this ceaseless, irreversible increase in entropy, this cosmic tendency towards greater disorder, is what fundamentally creates what we perceive as the unidirectional flow of time. Everything you witness around you, the majestic spirals of galaxies, the incandescent glow of stars, the intricate complexity of life, of human beings, even the conscious mind grappling with these very ideas, all of this, in its current highly organized, structured, and low-entropy form, is a direct consequence of a singular, profoundly improbable fact, that for reasons yet unknown, the universe at the moment of the Big Bang was in an unimaginably, improbably ordered low. It was a cosmic baby of immense potential. The progressive, irreversible movement from that astonishingly ordered, primordial state of the universe towards an ever-increasingly disordered, less structured condition is what we interpret, what we feel, as the passage of time. It is precisely analogous to the irreversible mixing of the ink in the water, a clear progression from a state of distinct separation to one of uniform blending. And just as we would be utterly incapable of discerning the direction of time if we were presented with footage of ink already completely and uniformly mixed throughout the water, a state of maximal homogeneity where all gradients have vanished, so too, In a universe that has achieved its maximal entropy, the very concept of an arrow of time would cease to exist. There would be no discernible direction for events to unfold, no discernible before or after, because everything would be in a state of ultimate equilibrium, of absolute, featureless homogeneity. Change, as we understand it, would simply stop. The very fact that you, as a conscious observer, perceive a consistent, unidirectional arrow of time, in other words, the undeniable sensation of time flowing relentlessly forward, always from past to future, is, in itself, a profound indicator. It tells us that the universe, despite its immense age and ongoing expansion, has not yet Miman-Ho-1 rays, reached that ultimate, maximal state of equilibrium towards which it is inexorably drawn, in accordance with the laws of entropy. The cosmic clock is still winding down, still losing its potential for ordered change. And this brings us back, full circle, to the ultimate, chilling fate of the cosmos. Upon achieving the state of de Sitter space, that vast, empty, eternally expanding void dominated by dark energy, the universe will have reached its absolute maximum possible entropy. From that moment onward, the overall entropy of the universe will no longer be able to increase. And crucially, if entropy can no longer increase, it means that, in the familiar, conventional sense, nothing more can happen. For an event to occur, for any process to unfold, there must be a flow of energy, a rearrangement of matter, a transition from one state of organization to another. This requires a gradient, an imbalance, a difference in potential that allows for change. But in a state of maximal entropy, all such gradients have been smoothed out. All potential for change has been exhausted. The ink in the water has completely, irrevocably mixed, achieving its final, featureless state. Indeed, in a profound and deeply insightful sense, a synonym for the term entropy might well be homogeneity. Considering that the universe expands not from a single central point, but uniformly and simultaneously from every point within its expanse, when it eventually attains this state of exponential de Sitter expansion, an unsettling reality will emerge. Around any given point in space, no matter how insignificant in the grand scheme, it will be possible to delineate a sphere of observable reality. Beyond the boundaries of this sphere will lie a portion of the cosmos that is forever hidden, forever causally disconnected from anything within that sphere. This is precisely analogous to how those distant stars and galaxies we discussed earlier are already, and will increasingly become, irrevocably hidden from our future perception, fading into an eternal cosmic night. This ultimate pervasive homogeneity, this final, unchangeable equilibrium, this cessation of all meaningful change, is precisely what we refer to as the heat death of the universe. You might be asking, with a certain pragmatic detachment, a quiet sense of the irrelevance of such far-off events. What relevance does this ultimate far-future cosmic scenario hold for us? Why should this concept of heat death be considered worse than the simple, merciful demise of humanity? Especially since, by the time such an event occurs, we, as a species, would have long since faded into the cosmic dust, our brief existence a mere flicker in the grand expanse of cosmic time. And it is precisely here, at this critical juncture, that we arrive at the chilling crux of our initial inquiry, at the very precipice of the idea I alluded to at the outset of this journey into the quiet, unsettling depths of Xnoesis. For there is a single, profound nuance, a single, devastating implication that utterly transforms our understanding of this seemingly distant future imbuing it with a terror far more immediate, far more personal, and far more deeply disquieting than simple annihilation. It alters everything, fundamentally changing the stakes of cosmic existence. Prepare yourself, for we are about to plunge into the heart of that terrifying nuance, that single, devastating implication that was foreshadowed at the beginning of our discourse, and which, when fully grasped, can induce a profound sense of intellectual vertigo. To fully comprehend its chilling power, I invite you to pose two deceptively simple, yet profoundly unsettling questions to yourself. First, contemplate this. What inevitably transpires, what becomes an absolute certainty when you are granted or are immersed within an infinite amount of time? And second, consider this complementary idea. What happens, what possibilities emerge when you are enveloped by an infinite amount of space? The answers, when contemplated with genuine intellectual courage, when allowed to permeate beyond the immediate, are staggering in their scope and truly overwhelming in their implications. The answer to both of these questions in their ultimate logical extension is, quite simply, everything. Literally, everything that is physically possible within the fundamental, immutable laws of physics will, given an infinite stretch of time and an infinite expanse of space, not only happen, but happen an infinite number of times. There is no escape from this cold, relentless, mathematical logic of boundless opportunity. Let us ground this abstract, colossal concept in a more tangible, albeit still highly improbable, scenario from our everyday experience. Could I, for instance, in the seemingly secure confines of my personal dwelling, conceivably suffocate because, through some bizarre, utterly inexplicable statistical fluke, every single molecule of oxygen in my room spontaneously decided, against all odds, to gather itself into a remote, distant corner, leaving the air immediately around me completely devoid of the life-sustaining gas? Intuitively, our immediate, common-sense response is an emphatic never. The concept of entropy, as we have painstakingly established, stands as a formidable guardian against such a preposterous occurrence, a bulwark against spontaneous order. You will recall that disordered states are overwhelmingly, astronomically more probable than ordered ones. Therefore, such a scenario of spontaneous extreme ordering, all oxygen molecules congregating in one spot, is so incredibly improbable that no forensic investigator faced with such a peculiar demise would ever even entertain it as a plausible explanation. It defies all practical experience. However, when we utter the word never in everyday parlance, in the context of our limited human timescales, we are, more often than not, actually employing a linguistic shorthand. What we truly mean to convey is typically, or ordinarily, or with an inconceivably low probability that it effectively amounts to never within the timescale of human experience. A spontaneous decrease in the disorder of a system, a reversal of entropy, is indeed possible from a purely theoretical, probabilistic standpoint, a transient dip against the grand upward trend. It is merely, to use a more precise term, fantastically, unimaginably, mind-bogglingly improbable. Ordinary individuals do not, as a rule, perish due to the spontaneous congregation of all oxygen molecules into a single corner of their living space. But here is the chilling thought experiment, the profound extension of this probabilistic logic. If I were to remain in this room for an infinite amount of time, then, with an absolute, undeniable 100% certainty, that unfathomably improbable event would eventually occur. Given the guarantee of infinite duration, even the most statistically improbable configuration, the most astronomically remote possibility, becomes an absolute, unavoidable certainty. There is no escape from this cold, relentless mathematical logic. The dice will eventually roll that specific, impossible sequence. And this same inexorable logic extends with terrifying precision to the grandest scales of the universe. An endlessly expanding, ultimately empty universe, a universe that has reached the state of de Sitter space, might, at first glance, appear to be a void utterly devoid of any activity, a realm where nothing could possibly happen, a canvas of absolute quiescence. But this perception is profoundly mistaken, a misreading of the quantum fabric of reality. Even in the deepest, most pristine emptiness of space, where classical particles are entirely absent, a teeming, seething substratum of activity still persists. This is because, even in a vacuum, quantum fields are always present, imbued with a fundamental, irreducible energy, and these fields are never, ever perfectly quiescent. They do not maintain a constant, absolute zero value. Instead, their values at any given point in space are perpetually, subtly, almost imperceptibly jittering, vibrating with an inherent energy. These incessant, microscopic tremors are known as quantum fluctuations. They are the direct, unavoidable consequence of the famous Heisenberg uncertainty principle, a foundational tenet of quantum mechanics that dictates that certain pairs of properties, such as a particle's position and momentum, cannot both be known with absolute precision simultaneously. This inherent fuzziness, this fundamental unpredictability at the quantum level, manifests as a perpetual, energetic bubbling, even in empty space, a quantum foam of fleeting potential. And these quantum fluctuations, while usually minuscule and fleeting, possess an astonishing and potentially terrifying power. Given enough time, and when I say enough time, I am speaking of durations so vast that they utterly defy human comprehension, periods stretching into the multi-trillions of years, far beyond the current age of the cosmos. These unpredictable fluctuations can, occasionally, on the quantum level or even across far larger macroscopic scales, coalesce into truly bizarre and utterly improbable events. They are capable of momentarily nudging a localized portion of the system into a state of lower entropy, of higher order, of reduced homogeneity, a fleeting reversal of the cosmic trend. Therefore, even if we operate under the assumption that our universe had a definite beginning and is not spatially infinite, a scenario that, while possible, is not universally accepted, nevertheless, in an expanding universe, the sheer, staggering immensity of time and space that eventually becomes available means that profoundly, vanishingly improbable events can and indeed will occur with 100% certainty. The probability becomes 1, given enough rolls of the cosmic dice. It seems incredibly unlikely, for instance, that a fully assembled grand piano could spontaneously materialize out of the empty vacuum of space, purely as a result of quantum fluctuations appearing from nothing. Yet physicists, armed with the formidable tools of probability and cosmology, have dared to calculate such impossibilities. The renowned scholars operating within their theoretical frameworks, for example, have estimated that if one were to wait for a period stretching into a trillion times the current age of the universe, a number so vast it requires a profound effort of imagination to merely contemplate, a conceptual journey into the truly boundless, then you would, with absolute certainty, eventually observe a fully formed grand piano spontaneously appearing before your very eyes, a fleeting product of cosmic chance. The more improbable an event, the longer one would have to wait for its spontaneous manifestation. The complexity of its arrangement directly correlates with the statistical rarity, but the core principle remains utterly unwavering. If you possess infinite space or infinite time, or even more potently, if you possess both infinite space and infinite time, then any conceivable event, no matter how astronomically improbable, no matter how profoundly complex, will occur an infinite number of times. It is a mathematical certainty, a relentless, inescapable consequence of boundless opportunity. The universe, in its ultimate duration and extent, exhausts all possibilities, repeating them endlessly. The implications that we can derive from this hypothesis of the universe's ultimate heat death, when combined with the relentless, unyielding logic of infinite time and space, are truly capable of inducing not just horror, but a profound, paralyzing sense of intellectual dread, even a touch of that promised madness, in anyone who dares to contemplate them with genuine seriousness, without the comfort of quick dismissal. This, my friends, is the very thought, the central, world-shattering idea that so profoundly pierced Nietzsche's consciousness, the idea to which I referred at the very outset of our journey into the quiet, unsettling depths of Xnoesis. It is the greatest weight he spoke of. Several months following his initial thunderous illumination at Lake Silvaplana, after grappling with its overwhelming implications, Nietzsche, with characteristic intellectual bravery and profound caution, would commit this concept to writing. In his seminal work, Zot's The Gay Science, he would, with immense delicacy, and in a manner almost designed to soften the blow of its full impact, touch upon this deeply unsettling idea in the concluding, penultimate fragment of the book's initial edition. He titled this fragment with profound aptness, "The Greatest Weight," a testament to its immense intellectual and existential burden. The passage resonates with a chilling, almost hypnotic power, inviting the listener to place themselves within its disquieting scenario. What if, one day or night, a demon were to steal into your most solitary loneliness, into the quiet, inner sanctuary of your thoughts and say to you, "This life, as you now live it and have lived it with all its intricate details, every joy, every sorrow, every triviality, every profound moment, you will have to live once more and innumerable times more, and there will be nothing new in it. But every pain and every joy and every thought and sigh and everything unutterably small or great in your life will have to return to you, all in the same succession and sequence. Even this spider that now crosses your path, this specific moonlight between those very trees, and even this precise moment, this thought, and I myself, the demon speaking to you. The eternal hourglass of existence will be turned upside down again and again, endlessly, ceaselessly, and you with it, a mere grain of dust on the sands of time, eternally repeating. Would you not, upon hearing such a pronouncement, throw yourself down upon the earth, grinding your teeth in despair and cursing the demon who spoke such an appalling truth? Or have you once, in the course of your existence, experienced a tremendous, all-affirming moment when you could have replied to him with a resounding certainty, "You are a god, and never have I heard anything more divine, more utterly magnificent"? If this thought, this chilling possibility, gained possession of you, if it truly took root in your deepest being, it would transform you, altering the very core of your essence. And perhaps it would also crush you beneath its overwhelming weight. The question in all and everything: do you want this once more and innumerable times more? Would from that moment on lie upon all your actions, every choice, every thought, as the heaviest, most inescapable burden? Or how well disposed, how utterly affirmative, would you have to become to yourself and to life, to all its suffering and all its glory, to crave nothing more fervently than this ultimate eternal confirmation and sealing, this unending repetition. The final fragment of that same profound book, The Gay Science, Nietzsche, with a sense of prescient drama, titled Beginning of the Tragedy. And this very fragment, steeped in the implications of this monumental idea, this greatest weight, would later serve as the powerful, enigmatic preface for the magnum opus of Nietzsche's entire intellectual life. Thus spoke Zarathustra, a book for all and none, the central overarching theme, the very core concept that Nietzsche intended to convey through the intricate allegories and profound pronouncements of Thus Spoke Zarathustra, was precisely this: the eternal recurrence of the same. The concept of eternal recurrence asserts a radical and deeply disquieting vision of reality, that time, in its entirety, with all its specific events and intricate details, repeats itself in an infinite, cyclical fashion. It posits that all events, every single detail, every fleeting thought, every grand triumph, every agonizing sorrow, every specific arrangement of atoms, will continue to unfold in precisely the same sequence, over and over again, for all eternity. It is a universe caught in an endless, unchanging, perfectly replicated loop, a cosmic Groundhog Day, from which there is no escape. In formulating this profoundly challenging concept, Nietzsche was most likely operating under a set of fundamental premises that, while perhaps not fully informed by the intricate nuances of modern cosmology, nevertheless contained a germ of profound truth that resonates with our current understanding of ultimate cosmic fates. His reasoning likely proceeded along these foundational lines. If the universe endures for an infinite span of time, stretching into boundless eons, and if the total quantity of matter and energy within that universe is, by its very nature, finite and fixed, not created or destroyed, then, given an eternity for permutations to unfold, eventually every conceivable combination and arrangement of that finite matter and energy must by sheer statistical necessity, repeat. Not just similar combinations, not just rough approximations, but precisely the same dear combinations, down to the minutest atomic detail, an exact replication of every single moment. And here lies the truly astonishing, almost uncanny convergence. Even though Nietzsche was working centuries before the advent of our current sophisticated cosmological theories, before the discovery of dark energy or the development of the inflation hypothesis, his terrifying conclusion, born of profound philosophical intuition, may very well prove to be uncannily accurate. For this precise conclusion, this chilling possibility of eternal recurrence is demonstrably physically possible, not in spite of, but directly arising from the hypothesis of de Sitter equilibrium, as meticulously proposed by the astute cosmologist Andreas Albrecht. The core premise of this equilibrium version of de Sitter space is a breathtakingly audacious idea that the very origin of our universe, and indeed all the intricate complex phenomena that unfold within it, can be understood as the direct result of random, highly improbable fluctuations occurring within an eternally expanding, utterly empty de Sitter space, a space containing nothing but the pervasive, repulsive force of dark energy. In this model, at some point within this boundless, ever-expanding void, a quantum process, an incredibly rare and massive fluctuation, causes a localized region of this empty space to spontaneously jump into an extremely low entropy state, a tiny pocket of immense order emerging from the chaos. From this incredibly ordered, albeit fleeting and tiny, seed, a new universe, a Big Bang, emerges. This universe then evolves, unfolding its complex tapestry of stars, galaxies, and life, gradually increasing its entropy, losing its initial order, until it eventually reaches its normal, high-entropy state, once again transforming into an empty, eternally expanding de Sitter space. And then the cycle repeats, endlessly, without beginning or end. Just as those elusive oxygen molecules, having momentarily congregated in a corner through a highly improbable statistical fluctuation, would, given infinite time, eventually redistribute themselves evenly throughout the room, only to spontaneously regather again and again in a ceaseless dance, so too does the entire cosmic narrative unfold. A new fluctuation arises from the de Sitter vacuum, a new Big Bang ignites, a new universe is born, evolving and decaying, and then returning to the de Sitter state. And this process continues, endlessly, cyclically, for all eternity, a cosmic pendulum swinging between creation and ultimate dissolution. Of course, no one is asserting that the specific history of every single one of these new universes, born from such fluctuations, would be an exact, one-to-one replication of our own universe's history in every single instance. That would be a misinterpretation. But herein lies the true, mind-numbing horror, the profound power of infinity. Given an infinite amount of time, it is not merely a remote possibility, but an absolute, undeniable certainty that our precise universe, with its exact sequence of events, its specific arrangements of matter, its unique history, down to the most minute atomic detail, will repeat itself. And we, in all our ephemeral complexity, with all our thoughts, memories, and experiences, will be here again, engaging in precisely this conversation, experiencing this exact moment. And this repetition will occur not once, not twice, but an infinite number of times, in an endless cosmic reel. Moreover, if we expand our contemplation to include infinite de Sitter space, a universe boundless not just in time but in its spatial extent, then the implication becomes even more disquieting, even more profoundly unsettling. In every single moment, an infinite number of these Big Bangs, each evolving to precisely replicate our universe, our Earth, our lives, our every thought, are spontaneously occurring across the boundless expanse of this eternal vacuum. The sheer, overwhelming scale of such an idea is truly beyond human comprehension, capable of shattering one's sense of unique identity. I sincerely apologize if this exploration has, at times, felt overly expansive, if my words have seemed to wander like thoughts adrift in an ocean of concepts, reaching for the furthest shores of understanding. But it is precisely because we, as sentient beings, so often speak of eternity and infinity with a casual, almost dismissive ease, without truly pausing to genuinely contemplate, even for a fleeting second, the staggering, overwhelming implications that these seemingly innocuous terms truly encapsulate. We use them as mere descriptors, as convenient labels, failing to grasp the profound existential weight, the crushing philosophical burden they inherently carry. You might, at this juncture, attempt to retreat into a comforting skepticism, perhaps reasoning, but what concern is this to us? Even if the universe in its entirety repeats itself countless times, those future iterations would not truly be us. Our consciousness, our unique identity, would not be reborn, for identity is ephemeral and non-repeatable. Yet, this seemingly straightforward dismissal raises one of the most fundamental and deeply debated questions in philosophy and cognitive science. What, precisely, does it mean to be you? What constitutes the irreducible essence of your identity, yourself, your consciousness? Where does it reside? It is often heard, particularly from those who consider themselves non-religious or purely secular, The confident assertion that we live only once, a statement intended to imbue life with singular significance. But is there not, in that very assertion, a hidden layer of profound, almost dogmatic belief? A belief that might, ironically, possess a greater resonance with certain religious tenets, like the uniqueness of a soul, than with a purely materialistic scientific worldview. For, in essence, these individuals are implicitly declaring that their unique consciousness, their specific configuration of thoughts, memories, and experiences, is, in principle, impossible to replicate or recreate. This is a remarkably strong claim, one that, if dissected into its underlying premises, ultimately suggests that consciousness is something fundamentally distinct, something intrinsically separated from the material world, a notion that many scientific materialists would find deeply problematic, as it hints at a non-physical component. If consciousness is merely an emergent property of sufficiently complex physical arrangements of matter and energy, then, in a universe of infinite repetitions, the identical physical arrangements that produce your consciousness would inevitably reoccur. But let us return to the specifics of cosmic timelines and the unsettling implications of quantum fluctuations. How much time, one might reasonably inquire, would be required for a new Big Bang, sparked by these quantum fluctuations, to ignite within the eternally expanding de Sitter vacuum? While these are highly speculative calculations, push-button explorations at the edge of our theoretical understanding, some estimates suggest that such an event might occur approximately once every 10 to the power of 10 to the power of 10 to the power of 56 years. This number, utterly gargantuan, is so vast it completely defies any attempt at linear conceptualization. It simply indicates an unimaginably long stretch of time, a duration so immense it can only be expressed in nested exponentials. And here is where the profound, unsettling implication truly begins to solidify, twisting our understanding of reality. If an entire universe with all its intricate complexity, with its billions of galaxies and stars, with all its laws of physics, can spontaneously arise from a vacuum purely as a consequence of random quantum fluctuations, then, by the relentless logic of probability, it is far, far more likely for a comparatively simpler structure. This is because a galaxy, while still immensely complex, is less intricate and requires a far smaller concentration of matter and energy, a less improbable arrangement of quantum fields, for its spontaneous emergence compared to an entire, fully fledged universe. The leap in probability is astronomical. If we continue to follow this unsettling line of reasoning, this probabilistic descent into the bizarre, the probabilities become even more skewed, increasingly favoring the appearance of simpler, isolated structures. It would be considerably more probable for a single solar system to spontaneously appear from the vacuum than an entire galaxy. Or, to narrow the scope even further, it would be more probable for just one planet, our Earth, to spontaneously manifest, complete with its oceans and atmosphere, than an entire solar system. Or, even more disturbingly, for just the current moment you are experiencing, this precise instant, with its unique arrangement of sensory data and thoughts, to spontaneously flicker into existence, fully formed, divorced from all other moments of your life, a fleeting, isolated snapshot. But wait, the rabbit hole descends yet further, into realms of profound disquiet. In truth, it is even more probable, from a purely statistical standpoint given the vastness of time and space, for a single, isolated, conscious structure to spontaneously appear. Imagine, for instance, a complete human brain, fully formed, with all its neural networks and memories intact, suspended in the vacuum of space, existing for only a fleeting moment. This brain would contain all your memories, all your learned knowledge, all your personality traits, every experience that defines you. It would be actively imagining that it inhabits a vast, complex world and is, at this very moment, listening to a video in which a narrator expounds upon hypotheses that are, quite likely, beyond any definitive empirical verification, its constructed reality fully contained within its own fleeting existence. Are you starting to detect the subtle, pervasive illusion here? Because for you, as an observer, there is no discernible space or time outside the boundaries of your own consciousness, no independent proof of an external, persistent reality beyond your immediate perception. Consider the immersive experience of dreaming. You fall asleep, and almost instantaneously, you awaken within a new day, having experienced a night of complex, vivid, yet entirely self-contained reality, a world created entirely within your own mind. If, at this point, a creeping suspicion has taken hold, a feeling that I might be veering into the territory of abstract, almost nonsensical speculation, a kind of conceptual delirium, rest assured, this is not a novel delusion I am conjuring. Ideas precisely analogous to this have, for generations, profoundly perplexed and deeply troubled some of the most brilliant scientific minds in history. The concept of a brain spontaneously materializing in an otherwise empty vacuum is known as a Boltzmann brain, named after the Austrian physicist Ludwig Boltzmann, whose foundational work on entropy laid some of the statistical groundwork for such thought experiments. This concept gained a startling, renewed relevance around the year 2002, when a segment of the cosmological community, engaging in rigorous statistical analysis, began to express a deep, almost existential anxiety. Their concern stemmed from the realization that, in many prevailing theories about the universe, human brains, with all their intricate consciousness and memories, appeared to arise far, far more frequently as a result of pure, random quantum fluctuations in the vacuum than did entire, fully developed universes capable of supporting billions of years of cosmic evolution, eventually leading to the emergence of conscious beings through biological processes. The statistical scales were wildly, catastrophically tilted in favor of the ephemeral, fluctuating brain. The chilling logic is this: the spontaneous emergence of an isolated brain from a quantum fluctuation is, as previously emphasized, vastly, overwhelmingly more probable than the spontaneous emergence of an entire complex universe. If, as we noted, a new universe might only appear roughly once every 10 to the power of 10 to the power of 10 to the power of 56 years, a Boltzmann brain, in contrast, might arise in the vacuum approximately once every 10 to the power of 10 to the power of 50 years. The difference in these timescales, though still incomprehensibly vast, means that Boltzmann brains are statistically far more prevalent in an eternally fluctuating vacuum than normal brains that evolve within a full, ordered, and long-lived universe. This statistical imbalance leads to an incredibly unsettling, almost paralyzing conclusion. It suggests that, probabilistically speaking, we are far more likely to be these unfortunate, fleeting Boltzmann brains, spontaneously appearing in a desolate, empty universe, destined for an almost instantaneous disintegration, rather than beings who have genuinely evolved within a complex, long-lived cosmic history. And if this were true, it would imply that our most cherished memories of the past, our most deeply held beliefs about the universe's grand narrative, our very scientific understanding, would, in all likelihood, be nothing more than profound, convincing illusions, fabricated recollections within a momentary, self-contained awareness, a cosmic delusion. And, of course, the concept of Boltzmann brains is merely one relatively tame example of the strange things that infinite time and space can produce. The universe, within the framework of eternal inflation and the boundless possibilities inherent in an endlessly fluctuating vacuum, is capable of spawning an incomprehensible, truly terrifying array of self-aware entities, any and all configurations not explicitly forbidden by the laws of physics. We simply do not know the full scope of what an endlessly fluctuating vacuum could conjure into momentary existence. I shall refrain from enumerating further more disturbing examples. Indeed, I would strongly advise against any prolonged contemplation of such scenarios, as they can genuinely undermine one's sense of reality. Regardless of whether you or I personally happen to be Boltzmann brains in this very moment, the sheer existence and theoretical possibility of such ideas compel our attention, demanding a certain intellectual humility. When one contemplates the astronomically precise confluence of parameters that were necessary for the emergence of human consciousness, a complexity I have previously explored in discussions about Earth's unique, improbable place in the universe, a violation of cosmic symmetry, one cannot help but ponder. Is it truly a coincidence, a mere roll of the dice, or is there some subtle underlying hand of infinite time or infinite space at play, orchestrating these improbable conditions, making the seemingly impossible inevitable? The very notion of these quantum fluctuations, capable of generating entire universes or isolated brains with their fabricated memories, so profoundly contradicts our intuitive, deeply ingrained notions of a rationally ordered, comprehensible cosmos that a leading contemporary cosmologist, a mind at the forefront of our understanding of the universe, Sean Carroll, has famously labeled it cognitively unstable. It is not that the idea cannot be true, he posits. It is not a scientific impossibility. The real problem is that if it joins true, then in such a universe, we might as well abandon any and all attempts to understand the cosmos. For if our very existence, our memories, our observations, our scientific methodology are merely fleeting, statistical anomalies arising from a chaotic vacuum, then nothing truly makes sense. Our scientific models, our quest for knowledge, our very trust in empirical observation, all would be fundamentally undermined, rendered meaningless by the probabilistic tyranny of the infinite. Nietzsche, in his profound and often misunderstood philosophy, is frequently and quite erroneously characterized as a nihilist, accused of denying life, advocating for its meaninglessness, or embracing despair. This characterization is, quite frankly, one of the most superficial and inaccurate interpretations of his complex and ultimately life-affirming philosophical contributions. While the doctrine of eternal recurrence, when confronted head-on, indeed entails a profound, almost paralyzing sense of meaninglessness in the face of infinite, inescapable repetition, stripping away all external purpose, Nietzsche's philosophy simultaneously offers a powerful counterpoint, a radical antidote. His doctrine of the Übermensch, meticulously articulated in the very same Sauchtrin-Gubing Sauchtrin-Eula, was conceived as a radical demand, a profound challenge directed towards the human will. It was intended as a blueprint for how an individual could and must forge meaning and purpose from within, in a universe utterly devoid of inherent, preordained significance, precisely so that such meaning could exist through an act of courageous self-creation. The relentless, unblinking idea of eternal recurrence systematically excludes any comforting hope of a heavenly afterlife, any illusory promise of divine salvation, or any facile solace offered by conventional religion, by the assurances of science, or by comforting philosophical systems. It strips away all such comforting fictions, leaving the individual starkly alone with their existence. But it was Nietzsche's profound conviction that the Übermensch, this radically self-affirming being, this pinnacle of human will, possesses the ultimate courage to embrace this brutal, inescapable truth, and to utter a resounding, unequivocal yes to such a world, to such a life, to its eternal repetition. This affirmation would come, not from a place of naive optimism or ignorance, but from a profound strength of will, a radical acceptance of life's inherent suffering and its unchosen nature, shedding all the comforting illusions that humanity has, for millennia, used to shield itself from the stark realities of existence. It is an act of ultimate self-mastery. Interestingly, for those who might be inclined to explore fictional narratives that touch upon the profound themes of the Übermensch and the arduous, often brutal process of self-overcoming, one might find a resonance in Theodore Dreiser's Trilogy of Desire, particularly in the character of Frank Cowperwood. In the concluding volume of that powerful series, a subtle, yet profound, reference to the concept of eternal recurrence even appears, echoing Nietzsche's grand, terrifying idea, lending it a literary dimension. Tragically, and with a poignant sense of cosmic irony that imbues his philosophy with even greater weight, Nietzsche himself was acutely aware that he was not, in his own person, an Übermensch. He openly described himself as a, quote, decadent, a testament to his profound self-awareness, his unflinching intellectual honesty, and his deep personal struggle. For Nietzsche, whose own life was a profound and often excruciating tapestry woven with threads of chronic pain, relentless suffering from various ailments, pervasive loneliness, and intellectual isolation, the idea of eternal recurrence was not an invigorating challenge to be readily embraced. And, instead, it was an utterly devastating, paralyzing, and profoundly horrific concept, an emotional and intellectual burden he found almost unbearable. In his personal notes, written during periods of immense psychological and physical distress, he poured out his soul, writing, "I do not want to begin life anew. Where would I find the strength to endure it?" This raw human cry reveals the immense personal cost of his radical philosophy. Despite creating the aspirational figure of the Übermensch, and despite directing his intellectual gaze towards this ideal, listening to its hypothetical resounding yes to life, Nietzsche candidly admitted that he himself struggled, and ultimately failed, to truly utter that affirmative yes with the full weight of his being. Perhaps this deeply personal, almost incapacitating struggle with his own most profound philosophical insight is why Nietzsche, with a profound sense of self-preservation, referred to his most fundamental idea, his, quote, greatest weight, only sparingly. It appears in a single passage in The Gay Science, in two evocative fragments from Thus Spoke Zarathustra, once within his autobiographical work Aetia Homo, and a single mention in The Will to Power. It was as if he did not dare to gaze too long, too directly, into the terrifying, soul-shattering implications of this radical concept, understanding its potential to unravel the mind. 8 years after that thunderous moment of insight beside Lake Silvaplana, following the most intensely creative and intellectually fruitful period of his life, Friedrich Nietzsche succumbed to a profound mental collapse. The precise reasons for his descent into madness remain a subject of intense historical and medical debate. Various theories have been proposed. The effects of potent medications used to combat his chronic insomnia, a latent hereditary schizophrenia that manifested later in life, or a number of other complex physiological and psychological factors. However, no definitive consensus has ever been reached among scholars. Yet, hauntingly, a significant number of scholars and biographers genuinely believe that Nietzsche's ultimate descent into madness was, at least in part, of psychogenic origin. A direct consequence of the immense, unbearable psychological strain imposed by his own radical philosophical investigations, particularly the unyielding terror of the eternal recurrence. A concept that demanded more of the human spirit than even he could provide. Whatever its ultimate cause, the debilitating illness never released its grip on the philosopher. And on August 25, 1900, Friedrich Nietzsche passed away, trapped in a state of complete, impenetrable dementia, unaware of the profound legacy he had left behind. And so, for him, and for all of us who are, by our very nature, not Übermenschen, not yet equipped with that radical, all-encompassing strength to embrace such a relentless, infinitely repeating existence, there is, thankfully, a glimmer of cosmic reprieve. The heat death of the universe, that ultimate cold, dark end we have meticulously explored in all its desolation, is, in fact, only one among at least 5 plausible, scientifically described scenarios for the universe's ultimate fate. These diverse possibilities are eloquently detailed in the insightful work titled The End of Everything, Astrophysically Speaking, by a celebrated theoretical astrophysicist, a specialist in the grand cosmic narrative. This compelling book, which served as a significant source of inspiration for many of the ideas presented in this very monologue, meticulously outlines these various potential cosmic dénouements, each with its own profound implications. Crucially, not every one of these scientifically hypothesized scenarios necessarily implies the horrifying, soul-crushing possibility of eternal recurrence. There exist other pathways, other ultimate destinies for the cosmos that do not demand such a relentless, cyclical return to every agonizing moment of our existence, offering a different kind of finality. The author, a distinguished specialist in theoretical astrophysics, has crafted a work that, to my mind, is one of the most intellectually stimulating, most profoundly engaging, and most subtly unsettling books I have encountered in recent memory. It is astonishing to reflect that such a work, brimming with insights into the most fundamental questions of existence and the ultimate fate of all things, once seemed to languish in relative obscurity. This perhaps is indicative of humanity's general, understandable reluctance to truly grapple with these ultimate, unsettling questions, preferring the comforts of more immediate concerns. Indeed, a towering figure in theoretical physics, known for his visionary concepts such as the Dyson sphere, a hypothetical megastructure designed to capture all the energy from a star, once sharply criticized the broader community of physicists. In his seminal paper, Time Without End, Physics and Biology in an Open Universe, he lamented the pervasive neglect of the universe's ultimate fate as a serious area of scientific inquiry, implying a distinct lack of rigorous, dedicated research on this profoundly important topic. He wrote, with a touch of profound earnestness, "The study of the distant future today appears to be as questionable an occupation as the study of the distant past seemed 30 years ago. If the analysis of the distant future raises questions related to the ultimate meaning and purpose of life, then let us explore them boldly and without embarrassment. However, considering the profound, almost overwhelming implications we have meticulously explored tonight, the weight of these cosmic truths, perhaps, just perhaps, it is precisely because these questions delve into such deeply unsettling, existentially challenging territory that our inherent, human tendency is to shy away, to avert our gaze from the abyss. Perhaps, after all, some truths are best approached with extreme caution, or, in the quiet, comforting darkness of night, gently set aside, allowing the mind to find solace in the immediate, the tangible, the now. As always, and this is a truth that bears repeating with utmost clarity, a gentle reminder that anchors us back to the present moment. You must always bear in mind that a significant portion, indeed, much of what has been shared within this extended exploration, represents nothing more than carefully constructed, highly reasoned speculations. These are the boldest conjectures our scientific understanding allows, hypotheses that, while grounded in the best available data and theoretical frameworks, are by their very nature subject to the inherent uncertainty of all scientific inquiry. They may or may not ultimately prove to be confirmed by future observations, by paradigm-shifting discoveries, or by entirely new ways of understanding the fabric of reality itself. The universe holds its secrets closely, revealing them gradually, often in unexpected ways. The grand, intricate tapestry of the universe continues to unfold, revealing wonders and terrors, profound beauty and unsettling desolation, in equal measure. But for now, as these intricate thoughts gently settle in your mind, let the quiet hum of the cosmos envelop you. Let the vastness of time and space, with all its perplexing beauty and its profound mysteries, with all its potential for order and its inexorable march towards entropy, cradle you into a state of deep, undisturbed rest. Allow your mind to drift, unburdened by the infinite, finding comfort in the silence that precedes sleep. Sleep now, and dream of the universe, in all its boundless, unknowable glory.